Hello children, welcome everyone to the first session of physics. Today the chapter that we are going to start in physics is the very first chapter, that is the chapter of experimentation and measurement. Now before we begin with this very chapter, I would like to bring under your notice that this very chapter must have been very familiar with you as like you must have read this very chapter in the previous classes also, in class 8, class 7 as well in class 6 also. But those were the things or the parameter that you must have studied on a very brief note. Now when we are going to deal in physics related to this very chapter, we have to be very specific, we will be very precise and also exact. Why exact? Because physics itself is an experimental science, or basically we can say a science of measurements that deals with the exact science. So that is why the most basic aspect of the study of physics is the measurement of the physical quantity to be taken up. Now, what is a physical quantity? The physical quantity is simply which can be measured or which can be expressed with numerical values like 5 hours, 20 meter, 98 degree Fahrenheit. What are these? These must be very familiar with you. We know that this complete thing refers to as for the time is concerned. This complete thing refers to as the length or the distance part, and this as the temperature. So the temperature, the length, the time, these are known as the physical quantity. Now every physical quantity is having two parts in it. One, the numerical part, and the other one is the unit. Numerical means the number part, it could be 5, 20, 98, and the other one is the unit like hours, meter, Fahrenheit. These are the units. So first of all, why do we need physical quantity? Why do we need it? We need it so that we are able to have uniformity everywhere. Now, why and how do we use or how do we refer the word uniformity in the physics? Uniformity can be referred to as like, let's say that you are having a particular book. Suppose you have to measure this side of the book or the copy or the page, any particular thing. Now you don't have any scale. You don't have any scale to measure. Alright. So in that case, what are we going to do? We will be using probably the width of a finger or the span to measure. Alright. And everyone knows these are not fixed for every human being. These keep on changing as per the different body measurement. Maybe you are quite tall. In that case, your width of the finger is going to be different from your friends or maybe from your brother or sister. So whatever you are going to measure using the width of a finger or the span, that will be different from your brother. So in that case, using the finger, the distance of the step, the length of the foot, and there used to be many other things also which used to be measured in the ancient time, like the span, cubit, foot, but these were not having a fixed value. Maybe they are using, it is coming out to be of 4 times the distance of the width of a finger. When you are measuring, it is coming out to be 3 times. When your sister is measuring, it's coming out to be 5 times. So each of them is not having uniformity in the measurement part. So that is where the comparison part comes in. How do we be very sure that this particular thing is not getting changed, but how come the measuring quantity is getting changed? Because we were not having a fixed value to measure. Now in today's era, we are having a the fixed quantity through which we can compare, and that is what brings us to the comparison part. And yes, this is the process of comparison of a given quantity with the known standard quantity of a similar nature. Alright, so this is simply the process of comparison. It's very important, the word comparing part of a given quantity with the known standard quantity of a similar nature. To understand that in a more better way, let's take an example. Like if we are having a line, initially I do not know what is the length of this very line. Alright, the starting end point is A and the other end point is B for this line segment. Now I do not know what is the length. Maybe I can predict maybe 3.8 centimeter, maybe someone can say sir 4.5 centimeter. Yes, but we cannot be very sure unless we do not measure it. So we are going to use a scale to measure. Then only we can say that what is the actual length of this very quantity or this very length. So we are going to use a scale, and we came to know after measuring it comes out to be 4 centimeter. Alright, it comes out to be 4 centimeter. So this 4 centimeter refers to the length. So length is the physical quantity. Alright, length is the physical quantity, and the standard quantity that we are over here is doing a comparison. How are we comparing this thing? The standard quantity that we are using is the centimeter part, or the length of a scale for the measurement. Now basically what it contains two parts in it. One is the numerical part and the other one is a unit. Now let's divide it into smaller fragments of 1 centimeter each, because every fixed quantity is having 1 centimeter part that we have used. So if suppose we are using 4 fragments in it, so combining these 4 fragments, what are we going to obtain? 4 into 1 centimeter, yes, it will be 4 centimeter. So basically one complete thing is the quantity of a combination of a different quantities in it, or different standard quantities in it. So that is what it is very important, the process of comparison in it. Alright, now let's say that what is a unit. So the known standard quantity is selected to measure a physical quantity. That means, like let's say that we have used a scale. Now what is the unit present in the scale? We know that there are basically two units, one is the centimeter and the other one is the inches. So if we are using inches, so it will be like 1 inch is equals to 2.54 centimeter. So it depends upon you whether you are using the inch part or you are using the centimeter. So centimeter, inches, feet, all these are basically the unit. Now over here, what is the unit in the very first one? When I have written 5 hours, hours is the unit, meter is the unit, Fahrenheit is the unit. These are the units, and 98, 20, 5, these are the numerical part. Alright children, okay, let's continue. Now let's see the characteristics of the standard unit. The very first and the very foremost important part of this aspect is that it should be having a convenient size. Now what do you mean by this thing? It means that let's say that we have to measure the length of this very paper. Alright, we have to measure across the length of this very paper. So obviously the unit that we are going to use will be centimeter. We are not going to use kilometer. If we are going to use kilometer, so that will be an absurd unit. We do not write it down to be a 0.0005 kilometers or something. That is totally useless value, that we cannot have a particular, or we do not use it particularly to write down such a smaller quantity or such a smaller length. Whenever we deal in such a small length, we use centimeter as a unit. So that means, like if suppose when we have to use a distance between two cities, yes, in that case we will be using the kilometer part. Alright, so that should be a convenient size. When we use a smaller distance or smaller part of a length, we use centimeter or the meter, and when we use a higher length or where we are going to have a greater value, then we are going to use the kilometers. Next, it should not change with respect to place and time. Suppose you had the book when you went to America, now the same book you are measuring. Now you are not able to measure, or maybe when you are measuring the same thing when you measured in India, it was coming out to be like, let's say, 4 centimeter, 40 centimeter, be it anything. And when you are measuring the same thing in America, it's coming out to be 4.2 centimeter, 4.5 centimeter. Why? That means the size of the thing that you used is not of a good order, is not having proper measurement in it. So it should not be changing. Whatever be the actual length that contains in a scale, it should remain the same throughout the world. It should not change. Then it should be possible to define, that means it should be having proper measurement where we can read it out. It should not be perishable, and also it should be easily reproduced. So these are the different characteristics that should be present for every particular standard unit. Now there are basically two parts of it. One is the fundamental or the basic quantity, and the other one is the derived quantity. Now what are these two? Fundamental is basically the unit which is independent of any other unit. Like let's say when we have to measure a particular length, we'll be simply using a scale. The unit might be centimeter or the inches, and we'll write down the value to be as centimeter, 2.5 centimeter, 3.7 centimeter. It could be any particular thing. So we do not have to depend upon anything. No, we are not having this parameter. We do not have an area. We do not have a measurement of volume. We cannot calculate the length. No, it doesn't depend upon anything. Directly the value, and that becomes the answer for that very length or that very thing. So the examples could be like the length, the time, the temperature, all these things. Whenever we have to take a temperature, we directly use a thermometer and we get to know the value, how much is the body temperature, or a particular quantity, how much is it having the temperature in it, simply straight away. And so goes for the time. If suppose after 5 seconds, after 10 seconds, after 1 minute, we are easily able to differentiate between the different sub-multiple units of time or the multiple units of time. Now, what is the derived quantity? The derived quantity is any unit which can be obtained by a combination of one or more fundamental unit. Like let's say area. If suppose you have to calculate the area of a rectangle, if you are not having a length or if you are not having a breadth, you cannot calculate the area. Just like you used to do the questions related to the mensuration in mass. To calculate the area of a rectangle, right now we are being precise, and let's stick to the rectangle part. Suppose you have to calculate the area of a rectangle. We cannot calculate if we do not have the measurement of a length as well as the breadth. Only when we are having both the values or both the parameters, then only we can calculate the area of a rectangle. Same goes for the force. Force is equal to mass into acceleration. If we do not have the value of a mass of an object, we do not have the acceleration of a body, we cannot calculate the force. And so goes for volume. Volume equal to length into breadth into height for any particular cuboid. Alright. So density, mass upon volume. So these are the different things which depend upon the other parameters. Area is depending upon length and the breadth. Force is depending upon mass and acceleration. Volume is depending upon length and breadth and height, or volume is depending upon mass and density. So these are the things which are going to be calculated on the basis of the other values. So these are the ones which are better known as the derived quantity. Alright. Now the fundamental quantity initially consists of three very basic things. That is the time, the length as well as the mass. So these are the three things: the length, mass and time. Alright. Now what is the SI unit of length? We know that meter. What is the SI unit of mass? Kg, kilogram. We use grams also, but that is not the standard unit. System international basically. And the time we use is the second. Now apart from these, the other fundamental quantities, these are the very basic one, because this is what being applicable to everything, most of the thing. Now apart from these three, length, mass and the time, what are the fundamental one? Temperature, which is having a Kelvin unit. Luminous intensity, like how bright or how luminous a particular object is glowing. So for that we have a unit as candela. Electric current, A being ampere. Amount of substance, you must have studied in stoichiometry in chemistry, a mole, to represent a quantity that represents a pertaining to certain amount of substance. Angle, radian, we have many other units also. Alright. Then the one that comes under the derived will be acceleration. Unit is meter per square second, so that means it depending upon the meter and the square of a second. Density, kilogram. Mass, meter cube, cubic meter. What is this? This is the volume. Velocity, displacement upon time, so meter. So these are area, length into breadth, meter square. So these are the things that depend upon. So these are the ones that are going to come under the derived quantity. Alright. So this is what you can note down and you can go through this thing. Alright. Okay, let's move ahead. Now the next thing that we are going to study is the CGS, the FPS and the MKS. What is this? CGS, FPS and MKS, these are the three different standard forms which are used to measurement or used to measure particular physical quantity. As per the CGS is basically a French system. FPS is a British and MKS is basically the metric system. Now in the CGS system, that is what is the smaller unit that we use for this. C stands for centimeter, G stands for gram and S stands for second. So that is what it makes us CGS. British FPS, where S stands for foot, P stands for pound and S stands again for the second, and where MKS stands for M as meter, K as kilogram and S as seconds. So this is what is three different forms. Basically we use the MKS form for representation of any particular basic unit. These are the basic ones. Alright. Okay. Now we should be very well aware that apart from meter, there are different units also that we use to measure. It could be centimeter, it could be kilometer and various other also. We have decimeter, we have decameter, hectometer, millimeter. These are the different units. So some are higher, some are lower. How do we get to know which one is a multiple and which one is a submultiple? We compare it on the basis of the SI unit. What is the SI unit of length? Correct, meter. So any unit which is higher than it will be known as a multiple unit. Kilometer, hectometer, decameter, all these will be known as multiple units. and units lower than it, centimeter, millimeter, decimeter, these are known as submultiple. Clear? So there has to be a relation. Right now what we are having, we are looking into that what type of units will be known as submultiple unit and which type of unit will be known as a multiple unit. It is again on the basis of the standard unit, that is SI unit of a particular physical quantity. Alright. Now when we are having this very thing, so obviously there has to be a relation that exists between them. So what is the relation? Relation has to be very clear. You must have studied in the previous classes also, like when we asked, write down relation that exists between the SI unit of force and the CGS unit of force. So you straightway write down that 1 Newton is equal to 10 to the power 5 dyne. So dyne being the CGS unit and SI unit being the Newton. So there has to be a relation. So similarly over here, like let's say write down the relation existing between the CGS unit and the SI unit, or the submultiple and the multiple unit, or meter and centimeter. So 1 meter equal to 100 centimeter. So now over here what is the relation? The relation that we have shown is the submultiple with a SI unit, not a multiple, submultiple with a SI unit. Alright. And now we know that very simple form, 1 kilometer equal to 1000 meter. Now what is this relation? This relation is again the relation of a SI unit with a multiple unit. Over here we had a relation of a SI unit with a submultiple one. In this case we are showing a relation that exists between the SI unit with a multiple one. So these things should be very clear to you. Same goes for other units also. Alright. So go through all this thing that we have studied today. That's it for the first lesson. I mean the first part of this very lesson. Then after this, once you are very clear with all these units and all, then we are going to move ahead. But you should be very well versed. You should go and keep on revising these very things, though you must have studied in the previous classes, but there will be a standard that will be elevated. For that you need to be versed with all these things what we have studied today. Alright. Okay children, that's it for the day. Bye bye. Have a nice day.